Okay, good morning, guys. Here we are with notes for Unit 6, Lesson 2. This is unit circle stuff. Just so you know, I'm going to try and break this into 2 or 3 videos to keep the time of each down so you can find what you need to look at a little bit easier and you don't have to watch through a 17-minute video. So first thing, your formative quiz is to complete this unit circle just with degrees and radians, okay? So every one of these points, so this angle, 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 etc., okay? We want you to write in what does this angle measure in degrees and what's the corresponding measure in radians, all right? So you should pause the video now, see if you can do that. And if you don't want to watch the whole video, I will post these notes filled in. Sorry about that. I'll post these notes filled in if you just want to look there. Okay. One other point is that you've got these 2 questions here. Convert 135 to degrees and convert 3 pi over 4 to degrees. Sorry, this one's radians. So those you should be able to do it as well. All right, so finally now you can pause the video and we'll go through these angles. All right, this is 30, this is 45, this is 60, this is 90, this is 120, this is 135, this is 150, this is 180, okay? Notice I'm writing the degree sign for everything. That's important. Then we've got 210, 225. This is 240. This is 270. This is 300. This is 330. That's 0 degrees, also 0 radians. Also 360 degrees. And this guy here is 315. Okay, so those are all the angles in degrees. Now we'll do radians. I'm going to go with, I guess, orange here. Okay, this is, it's an ugly pi. Wow. Let's do that a little bit better. So this is pi over 6. This is pi over 4. This is pi over 3. Pi over 2. 2 pi over 3. 3 pi over 4. 5 pi over 6. And this is just pi. This is 7 pi over 6. This is 5 pi over 4. This is, let's see, 60, 120. This is 4 pi over 3. This is 5 pi over 3. This is 2 pi. This is 11 pi over 6. This is 45, so that's 7 pi over 4. And this guy is 3 pi over 2. All right, did I miss anything? Should be good. If not, I know you guys will let me know. All right, the radians and degrees thing. So 135 degrees, so that's 135 times pi over 180. So that is 3 pi over 4 radians. And 3 pi over 4 degrees, shocker, is 135 degrees. I should put a degree there and a degree here. All right, next page. Yeah, so trig on the coordinate axes. How should this work? So we talked about how trig is really measuring certain ratios in a right triangle based on the angle. However, in the coordinate axes, right, we have these properties that to the right is positive x, up is positive y. Okay, so if we're in quadrant 1, and by the way, the quadrants, that's 1, this is quad 2, this is quad 3, this is quad 4. These triangles have always a positive hypotenuse, okay? But here, this is a positive x, positive y. So in quadrant 1, everything's positive, right? Sine, cosine, tangent, all that. In quadrant 2, well, y is positive, but x is negative, right? So this is going to be a negative x and a positive y. So what does that mean? Cosine would be negative here, right? Cosine would be negative because of this. Sine would be positive, and then you could figure out the rest of the ratios from there. In quadrant 3, well, both are negative, right? So you have negative x because you're moving left. You have negative y because you're moving down. So sine and cosine are negative. Tangent's actually positive, right? And then in quadrant 4 here, in quadrant 4, well, x is positive, but y is negative. Okay, so sine would be negative because of this, right? Cosine would be positive. Tangent would be negative. So there's a little mnemonic, right? You can say that all students take calculus, right? So this means everything. All the trig functions are positive here. Okay? In quadrant 2, well, sine is positive, right? Cosine's not, tangent's not. In quadrant 3, tan is positive. Okay, so tan is positive. And you can probably figure out in quadrant 4, cosine's positive because of this. Sine is negative. So here I'm going to say cosine is positive. All right, we're going to do one more page, and then I might have to stop the video because I'm talking too much already. All right. So here we've got a couple things. Trig functions of angles in standard position, right? So first thing is to realize that we can use this quadratic formula here to solve for the hypotenuse, right? And then this is a review of all the trig functions that we did last time. Sine is equal to opposite over hypotenuse, cosine's adjacent over hypotenuse, tangents opposite over adjacent, right? So all these are really referring to the picture on the left, where if I draw this out, okay, this is y, this is x, it's going to be negative, and this right here, that's theta. Okay? If we solve for x and y, here and here, and we're in the unit circle, that's key. If we're in the unit circle, the radius is equal to 1, right? So if that's the case, then this x coordinate here is cosine of theta, right? Because that's going to be this x distance over 1, which is just cosine theta. And the y value here is going to be sine theta, because the sine of this is y over 1, which is just y. Okay? Some vocabulary: the central angle, the reference angle, and quad 1, 2, 3, and 4. Well, we just talked about this one, right? If you're looking at the quadrants, let me get red here. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4. So here, you know, they go counterclockwise. Counterclockwise. clockwise. The reference angle, that's just this. So this is a ref angle. And again, what that means, reference angle, is it's the angle that connects the terminal side, you know, wherever you end, which is right here, to the x-axis. It's a smaller angle. Central angle is right here. So it's the angle touching the origin. Okay? Yeah, let's do this one example, okay? It's the same thing. I don't know why I got double copied, but it says the terminal side of an angle in standard position passes through this point. Find the sine, the cosine, and the tangent of that angle. All right, so I'm gonna get out of red here, go to blue. So the way I usually do these is draw the scenario out first, okay? So if our point is -3, 4, doesn't have to be exact, but we're right there in quadrant 2, okay? And that means that this side is 4. That means this side is -3. And this hypotenuse is 5, okay? 3, 4, 5 triangle, or you can use Pythagorean theorem. The angle right there is a right angle. Okay, so actually, A is this angle, all right? But angle A creates this triangle. So really, all the trig functions of this angle are going to be the same as the trig functions of this reference angle, all right? So if we write this out, the sine of A, well, that's going to be 4/5. The cosine of A is going to equal -3/5. And the tan of A is going to equal opposite over adjacent, which is 4/3. All right, so we're done. We're going to stop the video, and I'll make another one going on from here.